Welcome back, dear friends. Without further ado, because I can't remember what I'm doing at the moment, let's get on with it. So the shaft is glued into that, and that's now turning nicely. There's the worm drive, captive, with a grub screw, so I can fix that once I know where to position it. What to do next? Well, for some reason I want to do this gear. Because there's all these other bits to add, which is lovely because you start there and then move along, but I just want to get this gear. A couple of reasons for that. I want to convince myself it's all positioned in the right place, and also this gear is supported by that, which is supported by this lump of wood, which also supports the horn, and I want to get the horn put on. So I think this is the next project. There are also two of these things on a sort of crank-like system, so as it turns it sort of, well, it gives a nice sort of movement, an additional to and froing. I need to drill them out, and I'm learning. Yesterday I managed to pinch my fingers in a pair of pliers while I was trying to drill out bleeding washers. How annoying. So I'm going to keep my fingers well away from the action. And unlike the previous explorations into digits damaging using the V-block, look! I'm actually using the clamp, and I've clamped that and I've tightened that, so I can keep everything well away from the sharp revolving bits. Because normally I would just hold that with my finger, this bit actually in here, and obviously the drill would snap. Oh, I ever learn. I've got an L for an M4 rivet and things, and I've still got undamaged digits. So I've got them drilled out, and I've also sanded down the sides. That's nice. Also, this with this particular gear, it makes it interesting because I mustn't touch that surface at all, that silver spray painted surface. Luckily, there's not sufficient dust on it to matter, which is amazing. I know I'd scratch it, get fingerprints on it, whatever, so I'm being ever so careful. There's the back bit I'm going to glue the short sort of stub axle in. And there's a funny little spacer, threaded spacers. I can't remember why I got them, but they're perfect for that. So that's that. I found a brass screw long enough. So the idea is that goes on there, and the M4 dome nut goes on the top. First thing though, oh, I've got that to hold it with now, is to delicately screw this onto the back. If you remember, I'd done it like this because the bit that I cut out of the 10mm acrylic makes the other gear. And then this just, it saves plastic, so, and looks interesting, and used all sorts of leftover bits for the original one. Let's get that screwed together. Then I can stick the red gem in the middle, trying not to touch anything. Or indeed, what's happened in the past, get a splatter of super glue on the beautiful silver surface. Nice. So the back of this gear just has a little stub short axle that comes through, another bit of 10mm, but this one has a bearing on each side. So it supports this this gear. Let's see how not to make one of them. Well, you know, I drill out a hole both sides, 30mm hole for the bearing, leaving a little bit in the middle, and on a laser cut hole, and the drill bit drifts a bit, and then the two bearings don't line up at all in any way. So I've just taken it back to the pillar drill and drilled a little bit extra out one side. And then if I put it on here, my spindle, if I drop the other bearing on, right, there's now room. You can see how awful that is, how badly lined up it is, isn't that dreadful? But with a little bit of baking soda and super glue, I think we can fix this. Right, we have some baking soda. What I'm going to do is, luckily this side isn't going to be seen, so I am going to put a little bit of super glue just down here, in the vague hope that it's not going to stick the bearing together. And then I'm going to get a little bit, it's a bit like using glitter, you know, when you're a kid making cards out of glitter. Luckily you can just blow away all the stuff that you haven't used. In fact, I'm going to suck away all the stuff I haven't used. And then I'm going to put a little bit more super glue around. The amazing thing about using baking soda is it sets instantly. and forms an incredibly tough material. It's so tough that you can machine it. In fact, I made a video on fixing a bearing in a G-Tech vacuum cleaner that had all melted. I think I did the same with a Flymo as well. I did. The bearings got stuck stiff and had whizzed round and melted all the support. And I basically rebuilt it using baking powder and super glue, and it was strong enough to machine, and both pieces of equipment are still working at the forefront of engineering. I don't know what this demonstrates, but it spins round. I don't know what that shows actually. I mean, it was resting on those two, so it should... Oh, it doesn't look too bad at all. How lovely. And can I get it off? Yes, I can. So I've managed not to glue the bearing together, and that will all be hidden, as I say, in the back. Looks like I might have known what I was doing. So I've got that pushed into there. Now we can see whether it sort of works properly. Look at that. That's pretty damn good. Excellent. And there's a centimetre spacer there. Oh, that's definitely a spinny thing. How lovely. And I've still got lots of movement up and down here, so that once I actually glue this wood onto the frame, I can adjust this so that the gears mesh perfectly. Oh, Mrs. Oh, and a little glinty gem in the middle. Isn't that pretty? Right, enough of that. Let's take the dog for a walk. It's that time again. Do you want to go for a walk, Zig? Come on then. Come on, Zig. That's it. Oh, yes. Big stretches. And yawns. Just when I thought it couldn't get even more exciting, look, I've got this fixed down. Even better still. 2 spinny things. It's such a joy having the adjusters here to sort of slide up and down. Oh, look at that. And it's just adjusted beautifully. To the extent where, when it stops, it's even, yeah, look, it just rolls back a little bit with the weight of that. Isn't that a joy? Excellent. Let's stop admiring that. Or the fact that there's a perfect gap between the two so they never knock into each other. Anyway, next job, I think I'm going to get the motor on actually, because that's going to sit on a prong up here to drive this first pulley. Like this, in fact. Having said that, I think during the meanwhile, I've forgotten to cut out these two bearing holders for this big disc. So I think I'll get them cutting and we can start on there. Oh, look, there's another one of those female Munson ring plates with some 10mm stud with a hole drilled in the middle for the wires. Oh dear friends. So here are the two bearing holders for the big Nipkow disc thing. And get them drilled out to accept the bearings. While they were cutting out, actually I thought I'd do this cheeky little bit here. That's nice, isn't it? Lovely. And the great thing is, with these stainless steel rivets, M4 by 25mm long, they make perfect axles, absolutely perfect, because they obviously are manufactured within very tight tolerances, so they're actually 3.9mm diameter, and you can just push them through and then drop a little bit of super glue on the other side, and it just runs in and sticks in. Not too much obviously, because you don't want to stick the whole thing together. But that's a really effective and simple way to do things like these pivot points. Right, so let's get drilling for bearings. I don't know why I made these so wide, the fixings. How can I drill these without getting in the way? Something like that perhaps. With hindsight, I think it would have been really good to screw these on and get them lined up before I'd put all that on so I could sit it on its top. Oh, how ridiculous. I'm not quite sure how I'm going to get to this. I tell you, having these drawers here is so useful. That's perfect just to rest the front on. and now I can easily mark it all and drill and screw and everything else. Lovely. It may be worth mentioning how I marked this out. I held this along the edge firmly, then used a bit of lead from an old propelling pencil, which is really ideal because you can get in right to the end of quite deep holes and mark it. Then I centre punched the marks with my centre punch. Then I drilled 2 pilot holes, 2.5mm each, into the 2 centre punches. And then I've put this on and screwed it in, and it's lined up perfectly. I'm so pleased. Lovely. So now I'll go ahead with this one. Another improvement I'm going to make in a minute to the drawing, the design, because this is laser cut, it would be really handy to have the centre of the bearing marked. So I'm just going to get it to engrave a line down, so that, for example, there where I've got the line, and I can just move it and line it up really easily. And this is what you do when you realise that you should have drilled and tapped and put a grub screw in a hole in the middle of the gear. You forgot. You drill a hole at a slight angle like so, and then you find your lovely drill tap and some isopropyl alcohol, and you do it like this. Thing is, the tap doesn't go far enough for the grub screw to actually reach the hole, so I've got a bullnose tap, so I'll try and work out how just to finish that last little bit. Well, that's handy. I found some sort of tap wrench thing with the top missing, bit of isopropyl, and hopefully that'll give me enough surface to get some decent, well, enough torque to finish cutting the thread. Grub screw in, turn it over, and some isopropyl alcohol ran through the middle and has ruined the paintwork. Oh, I do wonder if I have any idea what I'm doing sometimes, but luckily that's not going to be seen. You're only going to be able to see up to about there, so I'm not going to worry about it, which is great. We have another spinny thing. Oh look, it's even finding its centre of gravity. How lovely. Oh look, you can see the Nipkow thingy effect. These are all fitting together ever so nicely. Very, very close. I think the next thing is definitely, and I've got all the pulleys and things sorted out, so to get that motor mounted. Let's get on with that. Before I started painting this, I thought it might be prudent to sort out the metal work, the scratchy metal work. So we've got 242 or 3mm, I can never remember, Munson rings, but 2 bottom halves because I wanted a bit at the top so a pipe could go in, a copper pipe. I've cut a bit of studding off the end of a bolt to M10 bolt. There's the female Munson thing at the bottom, so it's going to support the motor like that. But we need a way of getting the wires to the motor, so what I'm going to do is to put this studding in the lathe and drill a hole up the middle. So the first thing is to use the centre drill. You've got a ringside seat here. I'm going to put some isopropyl alcohol on here just to, I don't know whether it'll help much, but it'll keep it cool, and I don't want to get it all smothered in oil. So we've got that painted up, we've got the motor installed, we've got a diode to the wrong way across the terminals of the motor to cancel out any back EMF that could cause interference. We've got the hole drilled through the M10 studding, we've got that glued into that base and there. We've got the holes drilled here with a hole for the middle, in the middle for the wire. We'll give it a go and try not to scratch too much paint off. I've got the motor screwed on with no mishaps, thankfully, and I've also constructed the drive spring belt thing. Some company called Wilsco. I think they made them for Meccano originally, but they're brilliant. These are just offcuts. You get several in each packet, and normally the new ones come with a sort of feathered down end, one end, that you untwist poke into the other end, if you sort of mean, and twist up, and they just lock together. What I've discovered is you can also lock them together just by getting two blank ends, just lining them up carefully, pushing them together, and then twisting them together, and just a few twists, and they interlock really well. That's how I did the original ones on here that has run for weeks and weeks and weeks at the shows without any issues at all. So let's give this a go. I've got it connected up. Where's the button gone? And I'm running it at 2.5 volts. These motors will run at, look at that, will run up to 6 volts, I think. But they won't work really, they're very well made, and they will work efficiently down to quite a low voltage. Look, let's turn it round. How exciting. You can see where the drive belt goes. They're really good spring drive belts, those. I can recommend them. The grinding, these two gears at certain points, I remember having the same issue. Well, it's not an issue really, it's the sound of machinery, let's face it. But I put a load of graphite on the original one that quietened it down. I might do that on this. I'll see if it quietens down with use as they slowly bed together. Oh yes, we've got this one to make with another one of those spring linkagey things, pulleys, with the governor. I've got that to do. I've also got the other way, this one that turns the copper boiler. And once I put that on, then I know how to position this bit, the flame effect. Right, I'll have a think about what I fancy doing next. So now it's working out where to position this. And this one has the vertical gear that is run by the worm drive on here. So there's two captive bearings, one facing upwards, one down. So I'm going to work out where that needs to go along for the prongler to reach it and to engage with it. Well, that's lovely, because that gear is just the right height. It's centred with the worm drive, which is perfect, it's what you want. So now I need to work out where to mount this so I've got enough adjustment with the two slots. Oh, and I also discovered I haven't made these two. There's a pulley there and a pulley there. They're made out of 5mm thick acrylic, which I've turned the edge down with a cutter to make the pulley shape, and then glued something else on, which I vaguely remember might be 8mm with a grub. I don't know. I keep finding more bits that I haven't cut out yet. Despite how hard I look, there's always some more bits. So here are the parts for the two pulleys. There's the small one, which I've cut out of 5mm thick acrylic, 8mm thick bit that I'm going to line up in the centre of that, which I've drilled and tapped out to M4 for a grub screw. And then this one, which is going to, it's got a 3mm bit here, that's going to glue onto the end of a bolt that supports the rotating copper boiler. That's it. Now obviously I need to cut into the edge of this the pulley shape for the ball chain to travel round. So in order to do that, I know how to do this one, because I can glue those together and then put some M4 studding in and fix that. And I suppose actually the way to do this is to get that bolt turned down to fit through the bearing so that I could glue the end. So I've glued them together. The 4mm shaft will fit through there. Grub screw in there, tighten that, put it on the lathe, then I can turn that down. Now however, the other one, this one, it's not a metric threaded thing, because it's a standard plumbing fitting, so it's some imperial one, which luckily I had these long bolts. What I'm going to do, work out how much of it needs to go into that boss or something to screw it in, and then turn down sufficient thread on this to go through two M4 bearings that will be sitting in there. And then the bit of M4 sticking out at the end, I'll then glue the pulley on, because it reminded me, having a look at the original one, that's how that works. It's really quite simple when you sort of remember. I've just spent ages turning down this imperial bolt to 4mm, the bearing slips on, and something's not right, because the hole in the end of this pulley is not 4mm, and I was thinking, oh, I wonder if I've got bearings that actually fit on that imperial thread, and I have 13 outside, 5 deep, 6 internal diameter. It's coming dripping back because I now remember that by just taking the top of the threads off, it fits through. Hence the fact it goes right through. Oh, but I have been a fool. But I'm going to make a note of that on here. Don't turn it down. I also need to change the drawing of this bit because the clearance hole in the centre on this is for a 4mm diameter shaft. I need it for about 7mm diameter. What, you want to see me struggle to drill a hole through a beautifully made piece of engineering and see it snatched up by the drill and completely shatter and ruin? I was about to do it like that, and then I remembered I had a spare chuck, lathe chuck. Oh look, hopefully it's not going to scratch too much paint off. This is a far preferable way of doing it. Oh dear friends, fingers crossed, I may have done it. And if I swivel the camera around and look in my bolts drawer, ha! There's a fresh imperial screw to ruin. It fits through. Lovely, copious notes being made as we speak. Finally, we've got it sorted out. Just taking the nuts clear off the front or the tops of the teeth, and the bearing now slides on. And I've left the end of it as it was so it screws nice and firmly into the bullcock float. Having an extra lathe chuck is so handy because I can now put the bolt in the middle. I've drilled out 6mm hole, which is fine. I can now glue that on there and glue everything to the bolt. I couldn't find the one I'd made before to cut the pulley shape, so I've just found one in the drawer and sanded it down on the sanding sheet. Well, sorry, ground it down on the very hard sanding disc. So that's fine. Always make sure you've got an angle below it so it can actually reach the workpiece. It's very difficult to see what's going on, but I'll do my best. So I've clamped that new cutting bit in a quick release thing, chuck, whatever, tool holder. That's lined up with the centre of the 5mm thick wheel that I've got mounted on the spindle, 4mm shaft. So I'm now going to focus. Now I'm going to start it spinning and cut a little thing in it, a notch. I won't show that because I really do need to concentrate and have my hands about me. So you end up with something like that, which is lovely. Right, I'll go ahead because the other one now, this one will be set, so I can get that in the chuck and do the same thing. So the paint's drying on these two pulleys. I've got all these bits lined up, which is most satisfying. So the worm drive is now turning the thingamajig, which is going to then turn the proper ball in the end, and there's a pulley on the front that's going to work the governor. So it's all coming on beautifully. I'm very pleased with how it's going, even though it's a miss-en. So whilst all that's doing stuff, I'm going to get on with the ball chain pulley thing there and the ball chain tensioner, because that's the thing, if you use ball chain you do need to have some sort of tension system, and it's performed by that spring there. So these pulleys are made from V-bearings, which are these, and you can put a nut on one side, because the base of a nut is slightly rounded, even though it's bigger than that centre part of the bearing, it won't rub against it. If you use a normal washer like that one, it will, and it won't turn. Actually, let me show you. So there's a bit of M5 stud, because these bearings have a diameter 5mm hood in the centre. Got a normal nut on one side, could be a dome nut. On the other side I've got a normal flat washer. If I pinch these tightly, this bearing will not turn, because the centre of the bearing is rubbing. So what I found is a very good solution is to cut out for a piece of 0.5mm thick metallic card a titchy little washer. That's what all these holes are. And to stop them all falling through the laser cutter when they're cut out, and for me losing them, they leave a titchy little bit of little link of card between the washer part and the outside part. I think that is 0.5 millimetre, and that provides just enough clearance then. Just put the washer back on, so I'll tighten that, hold it really tightly. It spins and looks beautiful. So with this one, because I wanted that to pivot, it was a bit squeaky, so I've got my stainless steel rivet. Put a titchy little drop of 3-in-1 oil on this part of the rivet so it's lovely and silent and smooth, and a washer, and poked it through with a drop of super glue on the back. And because these are 4.1 millimetre holes, the super glue gets drawn just into this back bit, not through into the front. One top tip which I got wrong once: try not to get the super glue and 3-in-1 confused when you've got lots of these jobs to do, because it doesn't end up well. I think that's probably a good place to stop. Thanks very much for watching. Hope you found it informative, educational and entertaining. Hope to see you next time. Thanks again.